This is the midterm exam review, page 5. Okay, so we'll start with question 12. It tells us that a cafeteria buys cups from a supplier and the probability of a defective cup is 8%. Okay, and then it tells us, assuming the probability distribution is binomial, if 15 cups are selected at random, what's the probability that exactly 5 of the cups are not defective? Right? So they give us the probability, okay, and something is either defective or not defective. All right? So they told us that the probability of being defective is 8%, which is 0.08. Okay? They've told us it's binomial. And they said 15 cups are selected at random. That means our n is 15. And then they want the probability that exactly 5, okay, so our x is 5, of the cups are not defective. Okay, this is the type of problem that trips a lot of students up, because the probability given in the problem is the probability of being defective, which is 8%. But what we're looking at in the problem is the probability of being not defective. So we've got to use the complement rule before we start. The probability of being not defective is 0.92. Okay, so now it's just a matter of using our formula, which I'm going to write here. The probability of x is NCX times pi to the power of x. My handwriting is so bad with this stylus. Times the quantity 1 minus pi to the power of n minus x. Okay, actually might, that's just too ugly. So pi is to the power of x. Okay, now it's just a matter of slotting in our values. So our x is 5. Okay, so we have 15, C, 5, times 0.92 to the power of 5 times the quantity 1 minus 0.92 to the power of 15 minus 5. Okay? So what you're going to get, if you do this in your calculator, okay, and as mentioned before, the combination button on most calculators is Shift Divide, but you've got to put the n in first. So if you're punching this into your calculator, you'll punch in 15, then Shift Divide, okay, then this C will come up, and then you'll go ahead and punch in the rest. Okay, so if you do it on your calculator, what you're going to get is 2.125 times 10 to the negative 8. And as I've said numerous times in class, you've got to be able to change this into a regular number. So what this means is the number here means we've got to move this decimal point this many bumps to the left. Okay? So 2.125, 2.125. Okay, we're going to move it 8 bumps to the left. So 1, 2, 3, 4, 5, 6, 7, 8. So there's our decimal point, and we're just going to fill in these holes with zeros. Okay? So our final answer is 0 point, then we have 7 zeros. Okay, 1, 2, 3, 4, 5, 6, 7. And then we have our number, 2125. All right, so that is the final answer. Okay, so that's our last binomial problem. Moving on to questions 13. Approximately 68% of the total area under the normal curve is within how many standard deviations of the mean? Now, this question, it's checking to make sure you know what is called the empirical rule. And I was very pleased that one student in yesterday's class right away said, oh, it's on the formula sheet, because it is. Okay, at the top of page 2, is that correct? Yes, at the top of page 2, here we have the empirical rule. And the empirical rule tells us if we have a normally distributed pool of data, so something with a normal distribution, 68% of the data will be between mu plus 1 sigma and mu minus 1 sigma. 95% will be between mu plus 2 sigma, mu minus 2 sigma. And almost all, 99.7%, will be between mu plus 3 sigma and mu minus 3 sigma. So, the empirical rule tells us 68% of the data is within plus 1 and minus 1 standard deviations of the mean. So the empirical rule tells us 68% of the data is always between mu plus and minus 1 sigma. Okay, so the question asks us, within how many standard deviations of the mean? Well, 1, within 1 standard deviation. All right, question 14 is also about, it's related to the empirical rule. They've asked us almost all, 99.7% of the total area under the normal curve is within how many standard deviations of the mean? Well, if we just look back at our formula sheet, and really you should know this, okay, if you've been paying attention in class. The empirical rule, 99.7% of the data is within 3 sigmas, within 3 standard deviations of the mean, okay? So 99.7% of the total area under the curve is within 3 standard deviations, yeah? Mu plus and minus 3 sigma has 99.7% of the data. All right, question 15, that's a theoretical question. I will say, as I've said many times in class, if you don't know these characteristics, the rest of the course is going to be almost incomprehensible to you, okay? Because confidence intervals rely on an understanding of the characteristics of the normal. Hypothesis testing, you have to understand the characteristics of the normal. So really, you know, these are incredibly important to memorize, okay, and to understand. And I've made a video about those. It's called Normal Distribution, strangely enough. So if you don't understand what's written on the answer key on BB Learn, you need to watch the video on the normal distribution. So that is page 5 of the midterm exam.